So last time we started talking about how to describe random variables using some distribution functions. So basically, we said that okay, if we have a random variable, we are interested at the end to find it in terms of how is this probability of one, because the probability distributed among the different values of random variables. Okay? And we gave this example of tossing the coin 3 times. We defined what we call the cumulative distribution function, or what we call as the CDF, cumulative probability distribution function, CDF. And this should be used across the whole course from now until the end of the course. This is a function that basically describes how is this probability of one just accumulated over the value of x as x. So in order to find if x, this is x random variable, and this is just a number, small x, it's equal to the probability that x is less than or equal to specific value x. So the capital X here is the random value, x is variable, and the small x is just a number. Now, if you plot fx of x versus x, you should get what we refer to as the CDF. So basically, fx of x versus x. And this is something that starts from minus infinity as 0 and keeps accumulating until you reach maximum of كم شباب? 1, because it's a probability function. It's probability that x is the same. So basically, it has to be 0 at the minus infinity. It has to be 1 at the infinity. And somewhere in between, it's decreasing or decreasing. Okay, and we gave the example of tossing the 3 coins. We say that, okay, what is the probability? Tossing the 3 coins, we have 8 outcomes, right? And we define one value as the number of hits. So we end up with number of hits. The only value taking value of this is value taking one value. 1, 2, or 3. 0 is the probability of 1 over 8. 2 is the probability of 1 over 8. And 1 and 3. And 1 and 2 have probability of 3 over 8. And you said, okay, now let's find the value of the function, which is the CDF, at different values. So fx of 0 is the probability that x is less than or equal to 0, which is 1 over 8. And fx of minus 0.5 comes from 0, because it's the probability that x is less than or equal to minus 0.5, which is 0. So basically, anything before 0 has a value of fx of 0, of any number before 0 has a value of 0. Now, and starts to be non-zero at 0. So basically, this is closed here. And between 0 and 1, it continues to be 1 over 8, because the CDF fx of 0.2 is equal to the probability that x is less than or equal to 0.2, which is the probability that x is equal to 0. And we said that in order to find the probability, the value, we go to the definition, and then we find the corresponding events, right? And we went through basically the whole function, and we ended up with this, what we call staircase function. That is continuous from the right and from the steep from the right. Okay? And we said that, okay, the amount of jump at every value is equal to the probability of that value. So the amount of jump at x equal 1 is x equal to 0 equals the probability at x equal to 1. Okay? This is a function that describes random variable. It gives us more mathematical insight. Now, instead of looking at the sample space, the details, or the random variable definition, issue values, and so on, we look at this function, and we see that for values that are very small, these are impossible values. بينما هنا معظم probability lies in the positive. So now, from looking at the figure, you kind of get more information about, quick information about the random value. Let's talk about the properties of this CDF. First of all, we said that we'll discuss most of the properties. At minus infinity, What is the value of fx minus infinity? Why? Because this is equal to, by definition, the probability that x is less than or equal minus infinity. Can a number be less than or equal minus infinity? No? Right? This is not possible. And because of that, it has 0. And always, all the CDFs have to start from minus very negative numbers as 0. And then starts accumulating. Because of that, we call it cumulative. It adds. As x increases, it either adds or stays the same. At infinity, what is the value of x, of fx? Infinity. 1. Why? Because this is equal to x less than or equal infinity. Can any random value have a value more than infinity? Infinity is the argument, right? So basically, it has this is the certain event, and hence the CDF has to be bounded by 0 and 1. Why is that? Because it's a probability function. Now, if I want to compare the value of the CDF at two different values, x2 and x1, which one? What is the relationship between them? x2 has to be at x2. It has to be either bigger or the same. Why? Because every time fx of x1 is the probability that x is less than or equal x1. So basically, it includes everything before this point. Bainama fx of x2, it's the probability that x is less than or equal x2, which includes every value before x2. Right? However, this part includes this part. So it's either the same, equal, or at x2, it's either the same or larger than at x1. Okay? And this makes the function, the CDF, as non-decreasing. Non-decreasing function. It either increases or stays the same. And this is why we called it cumulative, because as x increases, we accumulate more probability. Okay? This is why we call it cumulative distribution function. Now, if I want to find the probability that x lies between two values, x is strictly larger than x1 and less than or equal x2, then this will be equal to the value of the function of x at x2 minus the value of the function at x2. Okay. Why is that, Shima? Yeah. Exactly. نطرح الفاليو at x2 minus the value at x1. Okay. And the last thing is that this function, the CDF, is continuous from the right. ايش يعني continuous from the right? It means that we have a discrete. function. This is discrete because we have a discrete random value. If we have continuous random values, as we'll see later, we have continuous functions. So continuous from the right means that at certain point, it's basically closed here, has to be closed at that point. So it's continuous from the right. So the value at any number equals the value at the number plus epsilon as epsilon goes to. Okay, this is what we call continuous from the right. Nice, right? The column and backwards. Okay. Now, if I give you any function and I tell you, okay, check whether this is a valid CDF or not, what do you need to find? First of all, you need to check whether it dies, it's 0 at minus infinity, and it's 1 at infinity. Also, it doesn't include nothing in 0, either 1. And it has to be 0 and 1. Okay? I think the function negative, we have a negative function should not be a CDF. And the last thing is the two things basically continuous from the right and has to be non-decreasing. So this needs to be checked. So these 5 conditions need to be checked. Okay. Now, any question about this? As I mentioned before, I don't want to repeat this again. But this chapter is the backbone of everything that will come. That's in chapter 1. هذا أسوأ، هذا أهم، هذا مرة. آخر شيء بعد كده بعد أسبوعين ثلاثة كل كلام الحسابات بالفاليو بي دي إف سي دي إف and so on. You can understand الكلام هذا you will get it. Any questions now? So now coming to writing it mathematically. So now we understand how to plot it, to find the value of x at any value, and we understand the properties of this. Now let's write it in terms of analytical form, in terms of a mathematical form. We know how to plot it, let's write it in a mathematical form. Now, for discrete random variables, it's a stair type. ايش يعني stair type؟ It looks like this. That is continuous from the right and more maybe not continuous from the left. However, it has to be continuous from the right. So basically, we can see that before 0, the value 0, and it starts to be non-zero at 0. If x is 0, I always value is non-zero, which is 1 over. قلنا إنه هذه الستبس عبارة عن the probability that x equal مثلا هذه عبارة عن x equal كم؟ الجمب. Where was the jump? At 1, so x equal 1. Here, where was the jump? The probability of x equal 3. So the jump is always equal to the probability of the value at which we jump. Now, if we want to write this, we can write it as summation of shifted step function. So, for example, before 0, it's 0, right? Now, how can we write this jump? As a step function, right? Where is the step function located? At x0 equals 0. So it's u of x because it's located at x equals 0. And how much is the amplitude of the step function? Is the probability that x equals 0. Okay? Again, that the jump is equal to the probability x equal the location. And then 0. Now, after that, it continues to be the step function until we reach 1. What do we have at 1? Another step function, so another jump, another step. What is the amplitude of this step? It's the probability that x equal 1, and where is the location of the step? X equal 1, so it's shifted by 1. It's u of x minus 1, because it's shifted at 1. Now we continue to have the same value until we reach 2, where at 2 we have another jump. Of cam 3 over 8, which is the probability that x equal 2. This is the next jump. So if we jump, what do we need to add? A step function, right? Where does the step function start? X equal 2. So we have u of x minus 2 multiplied by the probability of x. And the last step has location of at 3. So it's basically it's x minus 3, u of x minus 3, with an amplitude of x equals 3. Okay, so in general, for x discrete, f(x) of x is a stair step function. And it looks like, in general, it has u, it's a summation of step functions, shifted step functions, shifted step functions. Okay, located where? At xi's, where xi's here are the values ايش حقت ايش of the random variable x. Now the xi between I equal كم 1 to n are the values that a random variable x takes. في الفانكشن حقنا هنا في example, what are the values that x takes? 0, 1, 2, and 3. So basically, f(x) of x will be a summation of shifted step functions. Where is the shift? At the values that x take, and the amplitude of every shift equals the probability that x equals that value. X equals 0 or 1 or 2 or 3. in this particular example. In general, for different x's, its probability of x equal xi multiplied by its step function shifted at x. So in general, it looks like a step function starts from 0 and so it starts from 0 minus infinity and ends up at come. So this is a typical fx of x. X had a 1, x2, x3, x4, and x1. Right? This is in
And you compare
now.
minus and x to x1 on
Only value takes values that are minus. One the value can take values according to definition. زي ما قلنا. مثلا pairing or passing an exam. X could be minus 1 or 1. It's in your coin. Hide this 10 out of 10. So this is the general shape of X خلينا بس متأكد هذه الجامز هذه مش شرط انها تكون نفسها معلش مرات تكون صغيرة ومرات تكون كبيرة. يعني مو شرط انها متساوية لكن انا رسمتها كانها متساوية. This is the general shape. طيب شباب any question؟ أي سؤال؟ طيب now this is what we call the cumulative distribution function. Cumulative means as x increases, the value of this cumulative function increases because we accumulate more values of x that accumulates more probabilities, right? As x increases, we are including more probability, more events, because the f(x) of x was equal to probability that x is this time a number of x. So as x increases, we are accumulating more probabilities. Now, if we differentiate this, this is basically a cumulative distribution function. As I increase x, it keeps adding probability, right? Now, if I differentiate, then I put in there a cumulative function. Cumulative means what? I'm adding, right? Every time I'm adding. If I differentiate a function like this, what do I do? Because it's slow, the rate of change, right? The rate of change of the cumulative function. So basically, if I differentiate this, what do I get? I get impulses, صح؟ ايش الامبلسز؟ عبارة عن ايش؟ الامبلس هذا عبارة عن كم قوته؟ probability that x equal this, right? 1. And هذا الامبلس حيكون كم طولها؟ probability that x equal x2, right? And so on. So basically, what if I add up these things? الامبلسز هذه if I add them up ايش يعطيني؟ 1 total probability, right? So the next function is some density function, which is the derivative of this, is a function that gives me how is the probability one distributed among different values of method density, mass density function. Mass density function of an object, the mass of this object is distributed around the formula. I have a mass density function. And the probability density function, sorry, the power density function. Power density, I take the power of a signal, how is distributed among different frequencies. In this shape, probability density function is called probability density function, PDF. Because it's a density function. It gives you how is this total probability distributed among the different values of y. So it's a density function. What does density mean? Gives you how total probability of one distributed among different values of random variable x. How is this total probability of one distributed among the different values of one? And because it's a density function, it's basically the derivative of these CDF. نحن قلنا CDF كانت ايش؟ Relative distribution function. It adds. هي كلمة integration. This, if you differentiate that function, you get basically the density function, which gives you how is this one, total one, distributed among the different values. هل معظم مركز at certain values ولا هو evenly distributed uniformly? Is it like the Gaussian, concentrated around the mean, an average, والباقي قليل ولا كيف شكله? So basically this gives you a density function. So if in our discrete case, إذا عندنا discrete random variable, قلنا احنا ال fx will look like shifted step functions, right? Shifted step functions at different values of x, weighted with amplitudes that are equal to the probability that x equals certain. Now differentiating this is a number. Differentiating this means differentiating what? Step function, right? So what do I get if I differentiate step function? Delta function. So in our example in the fog, if I differentiate dx, what do I get? I get a function that will look like this. With amplitude at x1, this is x1, and this is x2, this is x3, this is x4, and this is x5. Right? So basically at x1, شوف كيف صغيرة هذه. We have an amplitude of كم? Probability of x equal x1. At x2, we have a small impulse. This is the probability that x equal x2. At x3 شوية كبيرة كانت. Okay, so basically this will be that. Probability that x equal كم? x3. هذه كانت أصغر شوي بسيطة. Probability x equal x4. واخر واحده كانت صغيره ولا كبيره تتذكرها؟ صغيره شويه. شيخ. طيب واضح. It's probability x equal x. Okay. Now you can see if you want to play with this value, you can see that a good بدون الامر بس نشوف نرجع للسامبل ستيت without going back to that. I know that it has a good probability, random value that it has equal to x5. It has little bit of probability x2 and x4, and a little bit of x. هذا يعطيك at least visual and mathematical expression. طبعا. لا خلاص بعد كده انتهينا. لا شيء اصلا. No other values. It's one. So differentiating one gives you nothing. 0. Differentiating 0 before gives you nothing. Okay. So this is just additional some examples. If I have it, this is similar to our tossing the coin. Tossing 3 coins. Example. We have the step function at 0, its probability it jumps by 1/8 because the probability that x equals 0 is 1/8. At 1, it jumps by 3/8 and so on. Now differentiating this will give you 4 step functions at 0. This is equal to 1/8, which is equal to probability that x equal 0. At 1, it has a step so the impulse with 3/8. What is 3/8? Probability that x equal 1. And at 2, it's probability that x equal 2. And at 3 is the last one, probability x equal 3. So now looking at this PDF or probability density function, you can say that most of the probability is focused or concentrated around 1 and 2, لكن أقل شوي صح ولا لا؟ So at least you know how is your random variable behaving. This is another example. We have jump at -1, at 0.5, and so on. Now, if you look at it, you will have also impulses of the same length. Now, this is a continuous random variable. It's a continuous. تذكر الرولينج wheel that has numbers from A1 from A to B. So this is like an example of rolling wheel of chance that goes from A and back to B. Okay, so basically this stops randomly at any point. And this pointer can take any continuous value. That's verified measure. So basically, what was the sample space of the record? What was the sample space? A to B, right? Now I want the random variable to be of the same property, A to B. So basically, I am mapping 1 to 1. This X equals the sample space. Okay, so this is the sample space. This is the system Sx. Right. The range of X, right? The range that X takes values on. In this case, it's equal probable that random variable takes any value, right? Equal probable means it's the same. So the PDF will look like at 0 and then closed here, and it's basically in general here closed. It's basically between A and B and equally likely. Equally likely means that what? Means that if I integrate, means what? The total probability of 1 is equally distributed among the different values. But if it is equally distributed, what is the length here? What is the amplitude? This amplitude equal to coming. This is density function. It's the total probability of 1 distributed among the different values. Different values between A and B. And it's constant because there's no reason that it stops here more than here. So what is the amplitude here? It is equal to what makes the area under the curve equal to 1, right? It's a density function. Density function gives you the total probability. How is it distributed over the different values? So this amplitude should be equal to whatever makes the area equals 1. Because the area equals the total probability. Because of that, it's 1 over B of minus. Now, if you look at it from CDF point of view, from the CDF, fx of x. Now, if you ask yourself, what is the probability that x is less than A? What is the probability that x takes value less than A? 0, right? Because x cannot take value less than A. What about the probability that x, what is fx of C? C. What is fx of C? It's the probability that x less than or equal to C, right? Now, if I move C, if C increases, ايش تخيلوا البروبابيلتي هاي يصير فيها؟ It increases ايش رايكم؟ linearly ولا non linearly ولا كيف شكله؟ What does C mean? C is a number here. إذا what is C ايش يصير؟ Probability will increase linearly, right? Because simply هذه كأنها total and increasing C as if I am increasing the area of this part. So increasing C will make the function increase linearly until I reach B. When I reach B, what is the CDF at B? 1, because the probability that x is less than B, less than or equal to B is 1, because I know that x has to take values less than or equal to B. So we reach 1, and then we continue to be 1. Okay? And before that, it is 0. Now, if I differentiate this, I get the PDF. If I differentiate this, dx, this function, I get differentiating a linear function gives you a constant. Now, visually, how do you see this sort of growth of one distributed among different values? ماشي شباب من هذا الشكل ايش رايكم؟ هل الرandom variable biased towards certain value? Is it concentrated over certain values? لو تلاحظ between A and B it's equal value because it's constant. This is we call it uniform distribution, uniform random value, and it has many applications. For example, the phase of the signal arriving at a mobile station. The phase will be a uniform random value between 0 and 2 pi. So in this case, now without understanding the random variable and distributions and so on, every experiment I want to do, I have to go back again and analyze the whole thing. However, in the phase, for example, I know it's fair. I know I did some measurement, I know it's random. Now I apply everything that I know about the uniform distribution. It makes my life easier because everything has been developed for that random variable. أعرف الحد وأعرف الفاريانس أعرف كل شيء. Moments and so on. Any questions about what does the CDF or BDF mean? And relation there. من بعد البي ليش هذا ما يصير زيرو؟ Okay, let's ask you this question. What is the probability؟ خلينا نسمي هذه الفاليو ايش رايكم؟ W. What is the CDF at W? What is Fx of W? واحد من الشباب نرجع دائما للديفينيشن. هذا ما له معنى، هذا عباره عن نوتيشن شكل يسهل على نفسنا ايش؟ بدل ما ندرس نحمل معانا البروبابيلتي ذات اكس از ليس ذان اور ايكوال دبليو، بدل ما نحمل هذه سميناها اعطيناها نوتيشن، اعطيناها اسم شكل سميناها اف اكس ودبليو. اوكي، فدائما اول ما تشوف هذه ايش تسوي؟ جو باك تو ديفينيشن. ايش الديفينيشن؟ What is the probability that x is less than or equal to w? What is it? W is larger than B. الآن لو if you run the experiment, what is the probability that you get a number less than خلينا نقول A is 0, B is 1. What is the probability that you get any number less than B? Because I know that I get from 0 to 1 always. So 2, everything below 2 is certain. And because of that, this is equal to 1. Because W is larger than B. وأي رقم after B, you will find that it's certain that I get a number less than or equal to that number. Any question? So now the properties of the density function. What now? تكلمنا عن this function. What does it mean? How to find it from the distribution function. Let's see what are the properties so that at least understand how does it look like. First of all, it's a non-negative function. ليش؟ Why is it non-negative? CDF is non-decreasing, صح? A CDF that is non-decreasing, if I differentiate a non-decreasing function, what do I do? Slope دائما يا zero يا positive. Differentiating non-decreasing function gives me always a non-negative function. هذا أول شيء. ثاني شيء, because it's a density function, if I integrate it from minus infinity to infinity, what do I get? The total probability is equal to 1. So the area under the density function is always equal to, okay, area. الآن بالmathematics خلينا نكتبها بالإنجلش. Area under fx of x always equal to 1 because it's a density function, and if you add the density, whatever inside the density function, you get 1. Now, because the density function is a derivative of the CDF, then the CDF is the integral of the density from minus infinity. صح؟ Why is that? Because fx of x ايش كانت اصلا by definition? It's the derivative of the CDF. طبعا ده انا نسيت اقول لكم annotation. The CDF is capital F. The PDF is all is small f. Sorry. خلينا نعلمها عند مكان notation. Okay, so this is small f, small letter f indicates CDF. بينما capital letter indicates CDF. And the same notation goes. This indicates the random variable x, while this indicates only a number or dummy variable. Okay, so whenever you see in this class, from now on, a small f means that it's what? A PDF. So this is the derivative, and hence we get the CDF as the integral. And because it's the integral, if I want to find the probability that x is between two values, then I simply integrate the PDF between these two values. احنا قلنا هناك كيف نسويها؟ الCDF كيف نجيب هذه الفاليو؟ How to find this probability CDF? This is equal to fx at x2 minus fx at x1. What is fx of x2? It's the integral from minus infinity to x2. What is fx of x1? It's the integral. هذه عبارة عن الانتجرال from minus infinity to x2. While هذه عبارة عن integral from minus infinity to x1. So I am integrating the same function over overlapping periods. So this is equal to the integration in the overlap only, which is x1 to x2. Because the integral from minus infinity to x1 is common in both. There is no need to repeat it. Now the last point is, and then we'll start the quiz. If I give you any function, fx, how to find out whether it's a valid PDF or not? We need to check for several conditions. Our condition has to be positive and negative. Any condition, area under the curve equal to this. That's it. Two conditions. Okay? Any questions now? We need to study this part because this is very fundamental. As we go on, we are building on this. And next class, I'm going to manage different well-known random values. Comprehend these functions, PDF, CDF, and so on. You will have some different understanding there. So we are trying to review on. Right. Here to the back. Well, the surrounding the right and the left on the side. في واحدين بزيادة وراك مثلا everybody has a paper؟ طيب يلا نقول بسم الله بالاي دي والاسم بسم الله